Hello everyone, my name is K. Reddy, working as Assistant Professor in Tegal Krishna Reddy Engineering College. Welcome to my channel. My channel name is Accelerate Your Research. Okay, this video I will explain electrical and hybrid vehicles. This is R18 BTech Triple syllabus JNTU Hyderabad. This subject in fourth year first semester. Today I will explain this first unit 1, introduction. Syllabus conventional vehicles, basics of vehicle performance, vehicle power source characterization, transmission characteristics, and mathematical models to describe vehicle performance. This is unit 1. In my previous videos, if you want to watch this electrical vehicle related videos, okay, open my channel, Accelerate Your Research. In Accelerate Your Research in playlist, here electrical and hybrid vehicles, okay, click here, view full playlist. Okay, this total 6 lectures are my previous electrical and hybrid vehicle videos. Okay, total these six are related to second chapter and the third and fourth and fifth. Now this video I will explain unit 1. I will close this one. I will start my presentation. Okay, unit 1, introduction. In introduction, this is total 6 topics in first chapter. One is the conventional vehicles, second basics of vehicle performance, third one vehicle power source characterization, next transmission characteristics, mathematical models to describe vehicle performance. Total these 6 topics in unit 1. Okay, introduction to conventional vehicles. These 4 points are very important. The development of internal combustion engine vehicles, especially in automobiles, is one of the great achievements of modern technology. Okay, lot of research going on this automobile industry. Internal combustion engine means conventional vehicles. And second point, automobiles have made great contributions to growth modern society by satisfying many of its needs for mobility in everyday life. Next, the rapid development of automotive industry, unlike that of any other industry, has prompted the progress of human society from primitive one to highly developed industry. This automotive industry is rapidly developed comparing to other industries, other pharma, other sectors. This automotive industry is development is very fast. Next, the automotive industry and the other industries that serve it continue to backbone of world's economy and employs the greatest share of the working population. Next, this is continuous slide. However, the large number of automobiles in use around the world has caused and continues to cause serious problems the environmental and human life. The conventional vehicles have some advantages, some good disadvantages. Okay, these conventional vehicles have some disadvantages. The disadvantages are air pollution, global warming, and the rapid depletion of the Earth's petroleum resources. Okay, are now problems. These are the main problems: air pollution, global warming, and rapid depletion of the Earth petroleum. Okay, due to this, avoiding these drawbacks, recently lot of research going on in electrical vehicles. Okay, electrical vehicles, hybrid electrical vehicles, and electrical fuel cell vehicles has been typically proposed to replace the conventional vehicles in future. Okay, next, in the recent decades, the research and development activities related to transportation have emphasized the development of high efficiency and clean and safe. Okay, for high efficiency, clean and safe transportation system, these vehicles are replaced in upcoming present and upcoming days. So this is introduction. Now I will coming to topic. This is basics first topic. Basics of basics of vehicle performance. Next, vehicle power source characterization. First, I will explain vehicle power source characterization. This is vehicle power source characterization, same as a power plant characteristics. This is the ideal performance characteristics for vehicle traction power plant. This is the ideal waveform. In this waveform, x-axis is speed, y-axis is power and torque. Okay, this is ideal waveform. Now I will explain. This is a practical related waveform. This is a power plant characteristics. In power plant characteristics, have two. Here I have two figures. First figure is performance characteristics of gasoline engine. This is the conventional vehicle. This is performance characteristics of electrical motors for traction. This is an electrical vehicle. Okay, here x-axis is the speed in RPM. Here 1000 RPM, 2000 RPM, 3000, 4000, and 5000. This is the engine speed. Okay, this is the power in kilowatts. Here 0, 20, 40, 60, 80, 100. This is the power in kilowatts. First, this is the specific fuel consumption in y-axis and torque Newton meter. This is also y-axis. Total 3 y-axis and 1 axis. I will explain one by one. First, I will explain this speed and fuel consumption. When vehicle running at low speed and high speed, the vehicle consumes high fuel. When the vehicle it goes medium speed or base speed, the vehicle will drop fuel. Low fuel will consume vehicle. This is the graph. When vehicle going high speed, here 290 grams per kilowatt, like this units. Here also high. When vehicle going 3000 3000 engine speed, the fuel consumption is low. Next, I will explain torque and speed. When torque is high, the speed of the engine is low. When the torque is low, the speed of the engine is high. Here, speed in RPM. This is the torque and speed characteristics. This torque and speed. Next, this power and speed characteristics. When speed low, the power consumption is very low. When increasing the vehicle speed, the power consumption also will increasing. Okay, these three in single figure, power and torque and specific consumption. These three related to power. Next, I will explain performance characteristics of electrical motors for traction in this waveform, in this diagram. Here motor RPM same as first figure. 0, 1000, 2000, 3000, 4000 up to 5000. This is the speed. This is the motor power in kilowatts. Here motor torque. In the second figure, don't have specific fuel consumption. Okay, this vehicle will run with electric power, motor power in kilowatts. I will explain motors speed and this power. When the vehicle the motor up to base speed, the power increasing linearly. After base speed, the power is constant. Okay, the power is constant. After 60 kilowatts, power is maintaining constant. Up to base speed, here torque it maintains constant in nearly 7.5. Okay, Newton meter. After base speed, here speed increasing 1500 to 2000, 2000 to 2000 to 3000. When increasing speed, the torque will decreasing. Okay, here this is the torque waveform. Here total 3. One is the torque and the second is the power. Okay, this is the speed. Speed means base speed. Here showing 1500. This is the power plant characteristics. Okay, when increasing torque, speed decreasing. When decreasing torque, speed increasing. Okay, in electrical vehicles, power it maintains constant after base speed. Okay, here power increasing. This performance characteristics of electrical motor is related to same ideal waveforms. Okay, ideal performance characteristics of a vehicle traction power plant. This is the ideal waveform. This is the practical. Next, we will explain these two diagrams. This is tractive effort of internal combustion engine and a multi-gear transmission vehicle. What's vehicle speed? Okay, here multi-gear transmission and here vehicle speed. This is the tractive effort on wheel in kilowatts. Okay, this is the tractive effort of internal combustion engine and multi gears here, first gear, second gear, third gear, and fourth gear. Next here speed. X-axis is speed and y-axis is tractive effort and gears. When vehicle going with first gear, okay, or vehicle moving with first gear, the speed of the vehicle here mentioning speed, vehicle speed in kilometers per hour. When vehicle moving with first gear, the speed of the vehicle is low. When the vehicle it changes from we change from vehicle first gear to second gear, the speed of the vehicle here increasing. Okay, when gear changing from second gear to third gear, again speed also increasing. In fourth gear, the speed of the vehicle is nearly the maximum speed. Maximum speed means yearly 180 to 200 kilometers per hour. This is the vehicle speed versus gear. Next year, tractive effort on vehicle. Okay, vehicle means this is the tractive effort means we are talking in electrical machines torque. In electrical traction, we are talking tractive effort. Tractive effort means vehicle weight in normal traction, train weight, and some other resistance also will add rolling resistance and aerodynamic resistance. That weight also will add in tractive effort. Okay, here simply this speed and this gear ratio. When we are increasing gears, the speed will increasing. When we are decreasing gears, and decreasing means first gear, second gear, speed will low. When third gear, fourth gear, the speed will high. Next, this is tractive effort of a single gear electrical vehicle. What's speed? Okay, here up to tractive effort on wheel. Okay, when increasing speed here, the tractive effort weight decreasing. When decreasing weight, the speed of the vehicle is increasing. Here also same. When decreasing weight of the weight, the speed also increasing. Okay, up to base speed, the tractive effort, the vehicle weight is constant here up to 50 rpm. After that, here the tractive effort, the weight of the vehicle is decreasing, the speed all increasing. This waveform is nearly ideal waveform. Okay. Next, transmission characteristics. This till now I discussed vehicle power source characterization. Next, I will explain transmission characteristics. In transmission characteristics, the transmission requirements of a vehicle depends on the characteristics of power plant and the performance of the requirement of the vehicle. Okay, the transmission is mainly based on two. One is the power plant and the performance of requirements of the vehicle. Next, a well-controlled electric machine such as the power plant of an electric vehicle will not need multi-gate transmission. Okay, when in electrical vehicles we will not use any gate transmission. We will run with single gate transmission. That is the second point. However, an electrical combustion engine must have multi-gear or continuously varying transmission by multiplying its torque at low speed. These 2 points are very simple. Internal combustion engine, we use multi-gears. In electrical vehicles, we will use single gear. This second point is related to electrical vehicle. Third point is related to internal combustion engine. Internal combustion engine, we will use gears. In electrical vehicles, we will use single gear. These two are 2 points. For automobile applications, there are usually two basic types of transmissions. One is the manual gear transmission. Second one is hydrodynamic transmission. Now I will discuss this manual gear transmission and hydrodynamic transmission. This is the manual gear transmission. This is the diagram. In this diagram, I will explain parts. This is the engine. This is internal combustion engine. This is clutch or torque converter. This block is clutch or torque converter. Next, this is the transmission. In this transmission, I have a gearbox. Okay, this is the gearbox here showing transmission name. This is the final drive. Okay, this is the final drive. This is the differential. This is the driving shaft. This is the vehicle wheel. Okay, these are the main parts in conventional vehicles. In manual gear transmission consists of mainly clutch and gearbox and final drive and the drive shaft as shown in figure. Okay, clutch here. This is the gearbox. In gearbox here showing transmission. This is the final drive and this is the differential. This is the drive shaft. This drive shaft used for it moving the vehicle. This is the drive wheels. This is the wheels of the vehicle. Okay, this differential connected to wheels. Okay, here middle. This differential connected to two wheels. Okay, this transmission is connected to this clutch and input to the differential. Okay, this internal combustion engine connected to clutch input. This is the manual gear transmission diagram. Okay, next I will explain this figures. Tractive effort characteristics of gasoline engine powered vehicle. I explained this diagram in previously, same as tractive effort towards speed when vehicle. This is the ideal tractive effort. This is the practical vehicle going first, second gear, third gear, and fourth gear. When vehicle moving with fourth gear, the speed of the vehicle is very high. When vehicle is moving to third gear, the speed of the vehicle is low compared to fourth gear. Okay, when vehicle is going to first gear, the vehicle of the speed is very low. Okay, this is the electrical vehicle. This thick line is the electrical vehicle, single gate transmission. This is the conventional vehicles, first gear and second and third, fourth gear. Okay, gasoline engine, 4-gate transmission. This light lines, the thick lines is electrical vehicle with single gate transmission. Okay, this single gate transmission waveforms is nearly the same as ideal waveforms. This is the tractive efforts of a gasoline engine vehicle with 4-gate transmission and electrical vehicle with single gate transmission. This is related to a gear and a speed and a tractive effort. Okay, I explained previously this slide same. Next, this is the hydrodynamic transmission. This is the hydrodynamic transmission. In this hydrodynamic transmission, mainly have 5 parts. One is the impeller. Impeller name is, another name is the pump. Second one is the turbine. Third one is the reactor. Fourth one is one-way clutch. And fifth one is the output shaft. This output shaft is connected to the wheels. This is the one-way clutch. This one-way clutch control in conventional vehicles. This one-way clutch driver will controlling this clutch. Okay, this is the pump. This pump it pumping fluids in hydrodynamic transmission. Okay, this pump pumping fuels. This turbine will rotating with high speed. Okay, this reactor it sends back fuel from output to input. Output to input to means output shaft side to input shaft side. This reactor. Next, these 2 points. Hydrodynamic transmission uses fluids to transmit power in the form of torque and speed are widely used in passenger cars. This type of hydrodynamic transmission mainly used in electrical conventional vehicles. Vehicles means cars. Okay, they consist of torque converter and automatic gearbox. Okay, main torque converter and automatic gearbox. Hydrodynamic transmission. This is the practical diagram. Okay, hydrodynamic transmission. This is the input shaft. Input shaft connected to the. This is the input side. Output shaft connected to the wheel output side. Here the main parts pump. Okay, this is the pump. This is the turbine. Next, this is the fluid flow direction. Fluid flow direction. The direction will control reactor. Okay, input shaft pump is connected to the input side of the shaft. Next, turbine is connected to output of the output side of the shaft. Next, the reactor is connected to it sends secondary side to primary side pumping fluid. Okay, now I will explain this theory. The torque converter consists of at least 3 rotatory elements known as the impeller. Second one is the turbine. Third one is the reactor as shown in figure. Here pump. This pump is the impeller. Second one is this is the turbine. Third one is the reactor. Reactor is flow direction. This is the function of This is the function of reactor. Okay, here direction pumping fluids from primary to secondary. Next, the turbine will rotating. This reactor sends fluid from secondary side to primary side. Next, the impeller is connected to the engine shaft. Okay, here impeller means pump connected to the engine shaft. Here, this one. Next, the turbine is connected to the output of the shaft. The converter. This is the turbine. This turbine is connected to output of the shaft. Next, the reactor is coupled to external housing to provide reaction on the fluid circulating in the converter. This reactor circulating fluids in this total in this diagram for a secondary to primary. Next, the function of the reactor is enable the turbine to develop an output torque higher than the input torque. Okay, the function of reactor is generating output torque higher than the input torque. The main function of this reactor generating high torque. Next, this is the vehicle performance. Vehicle performance means first is the basics of vehicle performance. We'll explain last slide. Okay, this is the basics of vehicle performance diagrams. It to tractive effort of a gasoline engine powered vehicles with multi-speed transmission and its resistance. Okay, this is the tractive effort of gasoline engine powered vehicle. Gasoline engine powered vehicle means conventional vehicles with multi-gear transmission and its resistance. This is the diagram. In this diagram, I have three resistances. One is the first. This is the FR. FR is the rolling resistance. Rolling resistance here wheels. Okay, when vehicle moving in road. Okay, rolling resistance is this wheels and this road. Due to this road, some resistance will add in vehicle. Okay, that is the rolling resistance. Second one is the aerodynamic resistance. This is the FW. Aerodynamic resistance is due to air, opposing air. Third one is the grading resistance. This grading resistance is the alpha. When vehicle moving in flyovers or any hill areas, okay, the grading resistance will add. Total three resistance. One is the rolling resistance. Second one is the aerodynamic resistance and grading resistance. FR is the rolling resistance due to wheels. Aerodynamic resistance due to air. Third one is the grading resistance. Grading resistance due to this angle theta. Okay, now I will explain output. This characteristics is the tractive effort and rolling resistance. Okay, tractive effort means vehicle weight in stopping condition when vehicle moving on road. Okay, these three resistances will add. Okay, additionally, tractive effort, vehicle weight plus and other resistances. Total have this y-axis here speed. This is the maximum speed. Okay, here when alpha this angle is 0, the resistance percentage is 0. Next, the angle alpha angle is 5 degrees. The resistance 8.7% will add additional resistance. Okay, resistance due to grading resistance on grading. Okay, when this alpha angle is 10 degrees, additionally 17.6% resistance will added vehicle. Okay, when alpha angle is 15, 26.8% resistance will means, if example 100 kN in normal vehicle. Okay, when vehicle on road 15 degrees. Okay, again 126.8%. Okay, weight tons increasing vehicle. Next year, vehicle alpha angle is 20 degrees. The resistance, rolling resistance is 36.4%. Okay, additional weight. This is the when alpha angle is final 30, the rolling resistance of the vehicle total 57.7%. Additional weight will be added vehicle. Okay, this is the performance characteristics of conventional vehicles. Okay, this is the diagram. These are the resistances FT and FW and FR. Okay. Okay, thank you for watching this video.